know we're a little bit late, so I'll just kind of run through the first slides a little bit more quickly. So just to give you some context, we're part of the Opening Gateways Title V grant. It's a collaborative grant with BMCC. It's a 5-year grant. And there's really an enormous amount of people working on this, which is wonderful. We have adjuncts, full-time faculty. We have teams in place at both campuses. And so it really has been a monumental effort. And we're in year 4 of 5 of the grant. This grant came about because we were facing challenges. We had gateway courses at both campuses, which were high-stakes courses, which seemed to be a bottleneck for our students. Many times they presented barriers for students to go up through the STEM track, and so we focused on these high-stakes courses. At both campuses, we chose to start with our algebra and trigonometry courses, and then moving up the sequence. Pre-calculus next, which is what we're currently focusing on, and next year we'll be focusing on calculus. And really, we were trying to hit all of the issues that, well, many of the issues that students face: financial issues, time, resource issues, support. So we're really coming at it from many different angles. And so our project activities are multifold. So we have a faculty development seminar, which runs, on a yearly cycle. We have open educational resource development, which simultaneously is running along with the faculty seminar. And then we do have campus-specific activities. Certain things are a little bit different on the BMCC side versus the City Tech side. So for instance, at BMCC, they have a supplemental instruction program, which they're developing there, and they're doing great work. On the City Tech side, we're doing work with the Open Lab, which you'll hear about momentarily. So there are some differences. Concentrating now on the open educational resource development, we have 2 parts of that. So the faculty seminar that faculty fellows participate in, it's a year-long commitment, and they go through a series of seminars where they learn some pedagogies, active learning strategies, advisement, best practices. It's really, like I said, it's well-rounded. And once they go through the seminar, they commit to teaching the course we're focusing on. Again, this year it's pre-calculus. In the spring semester, they teach their course, and they're implementing activities that they have developed as they were going through the seminar. And so we really do highlight STEM applications. City Tech has a variety of programs. We want to highlight this interdisciplinarity here. And so we encourage our fellows to not only take the pedagogies that they learned, but also highlight real-world applications. And so I'm just going to give you a couple of quick examples of activities that our fellows have created for our courses. So this one is by our City Tech fellow, Suman Ganguly, and he's been with us several years. So he came in the first round, and he's kind of one of our superstars, so he keeps coming back year after year. He's an adjunct professor, and he's really wonderful in being a mentor and a leader for the other fellows, building this sense of community, which is really great. And so his activity here, which he did in his class, was really cool. He had his students try to estimate the height of the Empire State Building. And so he had them go on Google Maps and get a distance from Google Maps. And then he had them use either a physical clinometer or an app on their phone, clinometer, to get the angle of elevation of the top of the tower. And so using then trigonometry, they were able to estimate the height of the tower, which was really cool. And he had a lot of positive feedback from the students when doing this. They had a lot of fun in the classroom. And then another one was an online activity using Desmos. For those of you who don't know Desmos, it's a free online application where it acts as a graphing tool, and you can also build your own activities or select from a library of activities. And you don't even need to sign in if you don't want to use this. It's an amazing application. And so one of our fellows, Kate Poirier, she created a Desmos activity where she had students observe, the motion of a wonder wheel. And then what was really wonderful is she gave them prompts and had them draw and also write. This is just a portion of the activity. And so in real time, you can see Desmos randomizes the students, anonymizes the names so you can flash up and see what your peers are doing. And so she had a lot of great success with this. activity. And so now I will turn it over to talk more about our OER development to Professor Parker.
Yeah, so while the, here, will you
Sure.
man?
Yeah.
So while our faculty fellows are developing OER resources in terms of activities that can be done in the classroom, we've also been doing work behind the scenes in preparation for these courses by programming in the WebWork, for the WebWork online homework platform. This is an open source platform, been around for a couple of decades now. It's been supported by MEA and NSF. And yeah, it basically allows us to make whatever problems we want for math. Let's go next. All right, so through this process, we've developed some best practices in terms of creating online content for students in mathematics. There's a whole lot here. I'm not going to go over all of these, but we do really focus on interacting with the students and trying to provide them customized feedback so that when they're doing their work at home, away from their professors, away from maybe their peers, they're at least not stranded if they get stuck. There's a lot of cutting edge features. Like I said, WebWork has been in development for 20 years. The platform now supports a lot of things that it didn't support originally. And these are just some of those new features. One of my favorites here is the GeoGebra support that allows us to give students manipulative applets within a problem and then gauge their interaction with those. So this is an example of one of those types of problems. This is a GeoGebra applet embedded in a WebWork problem. We don't see the full website here. But students are able to manipulate this vector, and then they're asked questions to, give the length and direction of the vector, and they're required, instead of giving students a specific vector to graph, allow the students to have some agency here and just kind of play, experiment with the applet, and there's freedom to choose their own problems. They've got to repeat the problem several times. They've got to choose different vectors to graph and give the results. And yeah, common errors are recognized, and we give them customized feedback. We also implement some scaffolded problems. So one of the things that's a concern in mathematics when it comes to online content is where are students doing their work? Are we only grading their final answer? Are we able to gauge anything in between? And so scaffolded problems are the solution to that. So in this case, the problem will unlock step by step as you perform the tasks necessary in the solution process. But then we also see in this particular example, I've given students the ability to just give the final answer if they don't need the scaffolded work. So we can make these supports optional. We can make them mandatory. Customized error messages are also available. This is a little bit small, I admit. But this is, you see the same problem. Here we've completed the first step, and we're now on to the second step of long division of polynomials. Not a very exciting topic. But what we can see, here is that the student has made some errors here, and their customized responses telling them where they should be looking in their work in order to make corrections. So instead of looking for a specific answer in each box, they're compared against each other to look for inconsistencies in the student work, and then the answer, the error messages target those inconsistencies and give students specific direction for fixing their mistakes. All right, so we've done a lot of work in terms of measuring student performance data. We see here in a couple of cases our college algebra course and also the co-requisite model with WebWork implementation has some standout achievement in terms of C or better results. This was from the fall semester and our most recent, our first rollout of the co-requisite model in the first place. But the WebWork sections have a tendency to do better, and we have some student researchers doing work on analyzing the performance data, but early indications are that, of course, student usage correlates pretty strongly with outcomes. So how do we get students to do the problems more often and more frequently? One of our experiments last year was to implement leaderboards and give students a sense of competition between courses and within their own courses. These are not necessarily grades. These are based on achievement points, which are earned at a higher rate than just the grade points. So students are comparing against each other. Yeah, sure, if you have more achievement points, you probably have a better grade, but we're not comparing students' grades here. So these were done by hand. They were updated weekly by Professor Bonanome in a Google Doc,
Yeah,
and students loved it.
Bananas.
So
It was a little bananas.
student performance on the final exam was outstanding. The experimental sections, median final exam score was 80 versus 65 for the control. And overall, the average was a raw 10 points higher out of 100. So next, so we decided those results were good enough to redesign the WebWork leaderboards and put them in the app so that students don't have to go elsewhere and we don't have to. Yeah, so these are live updated in real time. And as we can see, students can see where they are at in their course. This is the local leaderboards.
That's my class this
That's
semester. And Elmo is really working hard.
Yeah.
He's pretty amazing. And they keep track and
So
great.
then we also added a global leaderboard so that you can see Elmo here is 14th across all sections of pre-calculus that are using the leaderboards feature, the gamification features. And we also had a communication design student design new level badges for students as they earn more achievement points. There's a whole leveling up system and items that they can earn that unlock things within the assignments. Okay, I gotta keep speeding through. So one of the things that we run into frequently is then how do students get help when they get stuck on WebWork problems? So when they're working on their homework, what do we do? The usual solution, WebWork, like I said, is almost 20 years old. The standard solution has been there's an email instructor button, and so you can fire off an email to your instructor. Now, the problem is partially that communication is private, and this instructor ends up repeatedly answering similar questions over and over because students tend to get stuck on the same kinds of things, right? When something is challenging, more students are going to get stuck, and they're going to have very similar questions. So also students then, they tend to email after hours, when we're all asleep. So they turn to questionable sources like Yahoo Answers or Reddit or any other online forum that has activity 24 hours a day. So our solution,
It's the Open Lab. So what is the Open Lab? Some of you may have been at an earlier presentation, but it's CityTech's open digital platform for teaching, learning and collaboration. It's built using the open source platforms WordPress and BuddyPress, and you can go see it right here, openlab.citytech.cuny.edu. And it's been enormously successful at CityTech. It's served over 28,000 members of the community, students, faculty and staff since it was launched in fall of 2011. And if you want to go to the next slide. So anyway, since these are two open source platforms, we saw an opportunity to bring them together to help students. It's actually Andrew's brilliant idea. I'll give him all the credit for that. So in WebWork, if they get stuck on a problem, they can click this email instructor button, as Andrew was saying. But at CityTech, they see ask a question instead. And that redirects students to a community question and answers space on the Open Lab, where they can browse other questions that are related to the same WebWork problem, or they can ask their own questions, and faculty can respond. So if you want to go and see this, just a little bit of what it looks like.
We might point out that in WebWork, problems are randomized. There's a core framework around which parameters are randomized so that students are doing the same problem but with different numbers. And so they will frequently, when they have a question on a problem, you can go to the site and everybody else who has the same problem with different numbers, all their questions are available to you and along with their
Right,
answers,
so it's at an abstract level, they're seeing they're not going to see their
They're
own
not going to see answers
problem
to
and
their
have
own
their
problem.
problem be solved by somebody else. They have to kind of abstract things and think things through. So yes, so this is not just of academic interest to you, these are things that you can do as well. Web work is open source, obviously it has the problem library. Do you want to just say something about the problem
Sure,
library?
the WebWork, being around for 20 years has accumulated a lot of community resources that have been contributed. So 25,000 problems at all levels of mathematics, from basic algebra all the way through real analysis.
And
even.
some chemistry and physics
There's-
as well.
we're
Anything
working-
that's computational that you
The-
can enter numerically.
The WebWork community
Yeah.
is working to expand into
Absolutely.
engineering and physics, chemistry.
And so the problems that Andrew and team have been developing, there's these, what
We
we've been
shared
doing
them
at City
back
Tech, so they're like a coherent suite of problems that's specifically designed for these courses, but they're being shared back out through the Open Problem Library. So anybody can use
We'd like
them.
to
They're
see,
now
we would
right
like
there.
to see broader
Exactly.
adoption.
Yeah.
Exactly. So, talk to Andrew if you're interested in using them. The other thing is we have the Open Lab, till now historically has been just at City Tech, but now has been released through a collaboration with the Graduate Centre through something called Commons in a Box Open Lab. We can tell you a lot more about that if you want to pounce on us. We've got some cards we can give you. So that is something that you can use in your own environment. And then we're also the question and answer site that you saw a little bit of there. That's also open source. It's going to be released as a WordPress plugin so that anybody can use it. That's going to happen sometime in the upcoming year. So all of these things are available free for you to use. And that's anything else
We
have
crushed it.
there?
We were
now
so
have
worried
time.
about getting done
So
quickly.
now we have
But
time
can we
for
do like a
bit of
live demo
conversation,
real
yeah.
quick?
Do you want to
Yeah,
do it?
Can
Go
we-
ahead.
sure.
Yeah.
Go for it.
So think about your questions as well.
Ah,
So, yeah.
Yeah, we're happy to take questions now while
Yeah.
I kind of set.
Anybody have questions?
Good question. So obviously this is a great study, and it seems like you guys are building a lot of great tools. Like, how do you get your work out there in terms of kind of like, people at other campuses? Have you guys thought about like expanding the research that you've done and sending it across?
As far as the WebWork development that I've done, I've been trying to convince CUNY Central of the value in hosting a centralized WebWork resource, because what needs to happen at each campus is someone has to, because it's open source, somebody's got to do it. Somebody's got to install and administrate and like run the web software. And that's me at City Tech, and it's a big ask to go someplace else and be like, okay, we need somebody who has the computer skills and can, do system administration essentially. Whereas instead of repeating this, instead of repeating this process at every individual CUNY campus, why not host a centralized model and allow every CUNY campus to use it as a resource? And then the materials that get developed are more easily shared. Right now, we've pushed our resources to the problem library. If you were to install WebWork on your campus at this moment, you would have access to our problems. I could tell you where they exist in the library. But the library, like I said, is 25,000, 30,000 problems large. How do you find the most recent problems that make use of these new features in WebWork, as opposed to the problems that were built 15 years ago when these features didn't exist? So having someone, it's easier if things are a little more centralized so that things can be shared a little more easily. Anything we can do to facilitate that. Let me do a quick.
But it's a great question. As with all of these open educational resources, people,
Dissemination is tricky.
Yeah.
So as it stands, the MCC, they are administrating WebWork, and they have their own sets tailored to their courses. I know City College Andrew is assisting
I'm working
them,
with
getting up
City
and running.
College and their
So
Title
the
V
three-
grant to get some summer
Yeah,
bridge programs happening with with the college algebra and trig and pre-calculus courses. It's, so it's word of mouth.
it's going
It's
one
word
at
of
a
mouth
time.
and going to conferences and yeah. So here is the Open Lab web work question and answer site. And so we see here's a recent question from a student that's saying, I don't know how to come up with the complex number in A+BI form from just having the magnitude and angle. If we look at their problem, this is one of the interactive problems. So the whole problem is not going to load. The student is asked to manipulate complex vectors and and come up with their product in A+BI form. Let's see, I'm not logged in, so I'm not going to be able to actually respond. But students are asked, what have I tried? I've tried doing the sine of the angle, but it didn't work. So we do try to focus on this Q&A site and requiring students to write some and elaborate on what they've tried to do so that it does make helping them easier, but it also gets students in the habit of explaining themselves.
And
They
now
can
they
also
can snap
use
a pic.
images, yeah.
And now
exactly,
students
as
can
well.
upload pictures of their own work, which students complained about for a while. So how do I say what I've tried when what I've tried is really algebraic? When maybe I could, they don't like to type it out all the math either, and it's kind of hard to. So giving them the ability to just take a picture with their phone and upload a picture of their work makes our job so much easier. But then it also illustrates to any other student who comes along and sees that question, I see what they tried, I see the feedback they received, and I can identify where that student made their mistake. Maybe I made a similar mistake. Even though my problem is technically different, the parameters in the problem are different, but I can identify maybe I made a very similar mistake.
Any other questions? We've got I think 3 minutes left.
I guess I just wonder, do you see students tending to respond to students from only their own sections? Like how much across the, across section communication?
There's
do you
very
see
little
happening?
indication. You kind of have to look closely to identify who's in which class.
Mhm.
And because it's the open lab and students are able to write, their name doesn't necessarily reflect
Who they are, yeah.
who they are in entirely. It's not clear. So we do get some students responding to other students, but for the most part, we get faculty responding to students. Because the thing is that faculty receive an email notification when their students post a question. So if I had a student, they posted a question on the website, I get an email notifying me that that was my student who asked a question, and I get a link to come and answer their question. If they're not your student, well, you just have to be on the site and see that they had a question. And so it's not impossible,
People
but
do pop in, right?
Yeah.
Other faculty do
absolutely.
help
Yeah.
them.
I've had other
Yeah.
faculty respond.
Yeah.
If you don't get there in time and someone else is
Yeah.
on there, I've had other faculty respond.
I like
My
to
students
think of
very
this as asynchronous office hours,
Yeah.
so that if I have office hours and no one's coming to my office hours, I'm at least going to check out the Q&A site.
Yeah.
Some questions that are unanswered, let me just chime in and help that student. Then that helps that instructor. Maybe they help me out later by answering one of my students' questions.
And maybe your method of answering it connects to a student in a way that their
Sure.
professor
Yeah.
can, or vice versa,
Yep.
which is
Yep.
really great.
Yep. All right. I think that's all we got.